Hello, very good evening, everyone. So, hope you are doing very well. As you all know, that today we are going to cover the JEE PYQs from the chapter Chemical Kinetics. The questions that has been in the J examination previously in the previous years. That some of them we are going to discuss today. So, let's start our topic, that is NCRT chapter 3 Chemical Kinetics JEE PYQs part 1. So this is disclaimer. Let's begin with our first question. The question is JPYQ and it is covering the NCRT section 3.4 from our chapter Chemical Kinetics. The question is asking that the number of correct statements from the following is. So we have given some 4 statements A, B, C and D. You have to tell the number of the correct statements from the given 4 statement. The A statement says that larger the activation energy, smaller is the value of rate constant. So activation energy, remember E subscript A, right? And rate constant is represented by K in a rate law. So statement 1 is saying that as the activation energy increase, the value of the rate constant will decrease. The B statement is the higher is the activation energy, higher is the value of temperature coefficient. Second statement is also about activation energy, saying that if activation energy is the higher, the value of temperature coefficient will also be higher. Third statement, C statement, is at lower temperatures, increase in the temperature causes less change in the value of K, that is rate constant, than at higher temperature. What we are talking about, we are talking about the temperature, that in the lower temperatures, increase in temperature, if you increase the temperature, it will cause less change in the value of rate constant comparative to the change of the temperature at higher temperature. Okay, so the D statement is a plot, that is a graph of ln k, that is ln of rate constant versus 1 by t, is a straight line with the slope equals to minus of ea by r. So the fourth statement is telling us about a graph, that if you draw a graph between the ln k versus 1 by t variables, it is going to be a straight line and the slope of the line will going to be equals to minus ea by r. So the question was that you have to identify the number of correct statements from these A, B, C and D given statements. This question has been in the 2023 JEE examinations. The option is 1, 2, 3 or 4. I want to remind you again that you have to identify the number of correct statements, not the incorrect one. Okay, sometimes student might get confused or might in a hurry understood the question in a way that we are asking about the incorrect statements, right? Because that was easy thing. But in the question here which is given, the asking question is that the number of correct statement you have to tell. So okay, so first I just want to mention that read the question carefully. So you got some time here to solve this, then we will see the correct answer. Okay, so Let's see. So this is according to this given question. The correct answer is option C, that is 3. So the A statement, which is saying that the larger the activation energy, smaller will be the value of rate constant. Now, if you remember from the theory part, from the chemical kinetics, we relate the activation energy with the temperature or the rate constant according to Arrhenius equation, which is given by K is equals to A times e to the power minus EA by RT, where A is representing the Arrhenius factor, K is represented the rate constant, E is exponential term to the power minus EA. EA is activation energy, R is a gas constant, and T is absolute temperature. So easily you can compare, or you can relate the two terms, any two terms from this equation. So as the activation energy, that is EA, increases, exponential term, that is e to the power minus EA by RT, decreases. Try to understand. We have done these type of questions previously also in our previous lectures, but here we have done this concept basically of relating two terms from using this Arrhenius equation. Okay, so basically this is our first question that we are practicing. And as in this point mentioned, that activation energy, that is EA, if it is increases, if you see this expression, if this EA will increase, which is already present in the numerator part of the e to the power something, right, in the negative sign. So if this activation energy, that is EA, will increase, the exponential term, this whole exponential term, that is e to the power minus EA by RT, is going to decrease because it is present in the negative term in the power, right? So if negative power increase, E overall value of this exponential term will decrease, which will lead to the smaller value of K, because A is going to be a constant Arrhenius factor, right? So only K value will going to depend upon this exponential term. And if with the increase of the EA activation energy, the exponential term decreases, the K, that is the value of the rate constant, will going to decide upon them. So it will going to decrease, right? So smaller value of K, that will going to be lead. And therefore the statement which is given, that larger activation energy will give you smaller value of rate constant, is the correct statement, right? I hope you understand. We just write the Arrhenius equation, which is K is equals to A e to the power minus EA by RT. Then as per the statement, we have to relate between the activation energy and the rate constant, that is K and EA. If you relate between them, and if you notice that if you increase the value of the activation energy, that is EA, in this equation, if this EA will increase, this exponential term, this whole exponential term will going to decrease, right? Because e to the power in the negative something is present, which is increasing. That means e to the power, that this thing in the negative sign, will overall going to decrease, which will going to affect the rate constant, leading to its smaller value, right? So therefore our first statement, that is A statement, is the correct one. So we have identified our one statement that is correct. Now we will move to the second statement. So the second statement, that is B statement, says that higher is activation energy, higher value of temperature coefficient. So from the Arrhenius equation, K is given by A e to the power minus EA by RT. Now if E is higher, rate constant will be more sensitive to changes in the temperature. That means if there is a factor which we are considering, that how rate is going to affect with the temperature, and we have given the EA value change, that is EA is increasing, okay, that means EA is higher. So if activation energy is higher, rate constant will be more sensitive to changes in the temperature. Now after EA is higher, rate constant will going to be change, or will going to be show the sensitive nature towards the temperature. That means if the temperature will also change its value, either increase or decrease, then rate constant will going to affect, right? So the temperature coefficient will also increase. Okay, so if EA is higher, the rate temperature coefficient is also going to increase because it is going to affect the rate constant value. And as the B statement is saying that higher activation energy, higher value of temperature coefficient. Temperature coefficient means a term or a coefficient of temperature or a temperature factor which is going to affect the value of the rate constant in the Arrhenius equation. Okay, so if the activation energy is already higher, we are not saying it is increasing in the process or decreasing in the process, we are saying that its value is higher, then the rate constant is going to affect or will going to show the sensitive nature towards the temperature increase or decrease, right? So temperature coefficient also increase if the activation energy is higher because it will show its effect towards the rate constant value, and therefore the correct the B statement is our correct statement. This statement is also the correct one. So until now we have identified two statements that are correct, right? Now, if we move to the third statement, which says that at the lower temperatures, increase in temperature causes less change in the value of the rate constant than at higher temperature. What we want to say that at lower temperatures, rate constant is more sensitive to changes in the temperature. Why? Because the exponential factor, that is this e to the power minus a by rt in the Arrhenius equation, has a more significant effect. So rate constant is going to affected by both exponential term, or you can say activation energy, and the temperature. Now, if we have given that the value of the temperature is lower, if the value of the temperature is lower, rate constant is going to be more sensitive to the changes in temperature because the exponential factor in the Arrhenius equation has more significant effect, right? So if exponential factor is increasing or decreasing in the Arrhenius equation, that means it is going to affect the rate constant if the value of the temperature is lower already. Okay, so as temperature increases, relative change in the rate constant tends to be larger at lower temperature compared to higher temperature. So if you change the temperature, if you know that already the temperature is in the lower state, 2 degree, 3 degree, 0 degree, okay, now if you change the temperature or you increase the temperature like slowly, then the relative change in the rate constant tends to be larger because it will show that suddenly the temperature is going to affect too much to the value of the rate constant because it is already low, and you start to increase the temperature, that means the effect over the rate constant going to be larger, right? If you compare it to the condition when your temperature value is higher already, like 30 degree, 35 degree, 40 degree or more, okay, comparative to 0 degree, 3 degree, 35 degree is very very high, right? So if temperature value is already high and you are increasing the temperature more slowly and slowly, then the relative change in the rate constant will be comparatively lesser as if you compare in this condition where the temperature increase at the lower temperature condition, right? I hope you are understanding what I want to say, that how the change of the value of the rate constant is going to affect when you are increasing the temperature, when the temperature is already lower or when the temperature is already higher. Okay, so if the temperature is lower and then you are increasing the temperature slowly, then the relative change in the rate constant tends to be larger if you compare in the condition where temperature is already having a higher value and then you are increasing the temperature. At that time, relative change in the rate constant will be lower. Okay, so therefore this statement given in the option C is going to be the incorrect one, because it is saying that at lower temperature increase in the temperature cause less change, meanwhile it is going to be change larger at the lower temperature, right, in the rate constant value than at the higher temperature. So the C statement is the incorrect statement. If you have any doubt, if you don't understand the statement, the explanation, any part, you can ask in the chat box, please. Okay, so you can read it again and then you can understand better that what I want to say, how temperature is affecting the relative change in the rate constant value, if it is already lower or if it is already higher. Okay, so the C statement, which is saying that at lower temperature, if you increase the temperature, it will cause less change in the value of rate constant, is the incorrect statement. So until now, we have two statements that is correct, one statement that we identify as incorrect. Remaining is the D statement. So let's focus on that. So the D statement, first of all, it is saying that if you plot ln k versus 1 by t, that is going to be a straight line, and the slope of the line is going to be equals to minus of EA by R. So if we take the natural logarithm of the Arrhenius equation, which we already know, k is equals to a e to the power minus EA by RT. So if you take the natural logarithm of this Arrhenius equation at both the sides, you will get ln k is equals to ln of a minus ln of this e to the power minus EA by RT, and ln has base e, and this value is also going to be e. So ln e, like ln base e and e value is going to be 1, and whatever is in the power of the whatever is present in the power, that is going to be in product. That is the log property which we are using here. So ln k is equals to ln a minus EA by R t, or 1 by t. We are just separating it because the slope is given as minus EA by R. So just to identify the slope in the equation, we have written it like minus EA by R multiplied by 1 by t. Okay, so we are using here the logarithmic property, which is ln e to the power x is equals to x. Here in this equation, x is minus EA by RT. Okay, so remain is same, that if you take the ln of the both sides, first of all, the another property which we are using here, that if two values are in the product and you are taking the ln or log of the overall thing, that a into e, these two are in the product form, like a is multiplying by e to the power something, right? So if you take the ln of the right hand side, they will going to be like this. So ln a plus ln e to the power this, right? Now ln e to the power something is going to be that something which is present in the power. So we write it like this. So ln k is equals to ln a minus EA by R multiplied by 1 by t. I hope you understand this logarithmic property which we have applied here when we are doing the natural, or when we are taking the natural logarithm of the Arrhenius equation at both sides. If you have any doubt, you can ask in the chat box, please. I want to, or I will try to clear it out. Okay, so this equation which we just derive after taking the logarithm of the Arrhenius equation, which is given by ln k equals to ln a minus EA by R multiplied by 1 by t. First of all, you should know that if we have given that we are making the plot between ln k versus 1 by t, that means y variable is going to be ln k. That means y variable, that means when you plot the graph on the y-axis, it will be going to, y-axis will going to represent ln k, x-axis will going to represent 1 by t. So this equation which we just derive is in the form of y equals to mx plus c. How? Y is basically ln k, we already know. Okay, ln k you have to take as y. So y is ln k present at left hand side. M is basically minus EA by R, and x we have 1 by t. So with the x there is a m, right? So that's why we have identified that m is minus EA by R, x is 1 by t, because okay. Now this equation, that is y equals to mx plus c, is a straight line equation, remember. Okay, thus if you plot ln k versus 1 by t graph, it is indeed a straight line, right? Because it is matching with the straight line equation with a slope of EA by R. Therefore this state, okay, here minus should come. So the plot of ln k versus 1 by t is indeed a straight line, because in the equation we just saw y equals to mx plus c, x is 1 by t, y is ln k, and m is coming out as minus EA by r, that is negative slope. So the plot of ln k versus 1 by t is going to be a straight line having a slope of minus EA by r, and therefore the D statement is also going to be the correct statement. Okay, so if you count, we have the C statement only, which is the incorrect one. Other than that, A, B, and D are the correct statements. Thus, we have total 3 correct statements, that is A, B, and D statement. Okay. Okay, so let's move to our next question. This is a JEE PYQ, and this is covering the NCERT section 3.4 from the chapter Chemical Kinetics. The question is saying that we have given a reaction A converting to B. You can clearly see that A is a here reactant, B is here a product. Rate constant of given reaction at 200 Kelvin and 300 Kelvin are 0.03 minute inverse and 0.05 minute inverse respectively. Activation energy for the reaction in the joule is, you have to give your answer in the nearest integer, that means the integer form, and we have given some values which you can use in your calculation, which is ln 10 is going to be 2.3, r is going to be 8.3, you can use the r value as 8.3 joule Kelvin inverse mole inverse. Log 5 is, you can use it as 0.70, and log 3 as 0.48, log 2 as 0.30. Okay, so the question mentioned that it is given a reaction A converted to B. Rate constant for this reaction given at 2 different temperatures, 0.03 minute inverse and 0.05 minute inverse. You have to identify or calculate the activation energy for this given reaction in the joule. This question has been in the 2023 examinations, the JEE examinations. So the options that are provided for this question are 2520, 2000, 1530, or 2190. So you have given some time. Try to remember the concepts that we have covered in this chapter, which we can relate or which we can use while solving this question, right? We have given the rate constant values, the activation energy you have to find out. So you have given some time, try to solve this, then we will see the correct answer. Okay, let's see. So for this given question, the correct answer is option A, that is 2520. Let's see how. What are the given quantities? So first of all, the K1 is given, that is the first rate constant value, that is 0.03 minute inverse at the temperature 200 Kelvin. K2, that is the rate constant 2, which is equals to 0.05 minute inverse at the temperature 300 Kelvin. Now, using the Arrhenius equation to compare the rate constant, because we have to find out the activation energy which was present in the Arrhenius equation. So we use the Arrhenius equation to compare between the rate constant, because we have given the 2 values of rate constant at 2 different temperatures. We get log K2 by K1 is equals to EA by 2.303 R 1 by T1 minus 1 by T2. So this is the equation that we are going to use wherever we have given the 2 values of the rate constant at 2 different temperatures and we are talking also about the activation energy. In these type of questions, you use this equation. This is a NCRT equation marked as 3.22. So you already know that K1 and K2 are values of rate constant at the temperatures T1 and T2 respectively. And we have given the value of the K1, K2, T1 and T2. So you have to substitute these given values. So the equation will become log of K at 300 Kelvin temperature divided by K at 200 Kelvin temperature is equals to EA, activation energy, divided by 2.303 into R. R value we have to take as 8.314, or you can also take it as 8.3. Okay. Multiply by 1 by T1 minus 1 by T2. So log of 0.05, which is K at 300. K at 300 is 0.05, right? So 0.05 divided by K at 200 Kelvin is 0.03, first one. So log of 0.05 divided by 0.03 is equals to EA upon 2.303 multiplied by 8.314 multiply by 1 by T1. When T1 is 200 minus T2 is 300. Okay. So we put it every given values in this equation. Now, if you solve this, log of 0.05 by log of 0.03, the decimal will cancel out. Log of 5 by 3, which you can write it as log 5 minus log 3 using the logarithmic property. Log 5 value already given, log 3 value already given. You just have to subtract them. And when you subtract them, you can get some numerical here. Thing here is equals to EA. EA is what you have to find out. You can multiply these two quantities and you can also solve this fraction. Okay, so EA finally is coming out as 2519.88 joules, which you have to give in the integer form, right? Convert to the nearest integer as mentioned in the question. So the activation energy finally will become equals to 2520 joules. Okay, so this will be our correct answer. Let's move to our next question. So this is a JEE PYQ and this is covering the NCRT section 3.5. Okay, the question is saying that match the list first with the list second. The list first and list seconds are already given in this table. The list one is saying physioption ethnog in the A part, chemisoption in the B part, N2 plus 3H2 in the presence of iron converting to 2NH3 in the gaseous form, C part, and D part is analytical application or adsorption. Okay, so these are the 4 parts given in the list 1. The list 2 indicates the first one single layer adsorption, second one 20 to 40 kilojoule per mole energy, third one chromatography, and fourth one is heterogeneous catalysis. Okay, so you just have to simply match the list 1 with the correct match in the list 2. So choose the correct answer from the options given below. This question has been in the 2023 JEE PYQ. The options provided are A is connected with the second, B with third, C with first, and D with fourth. Or A is connecting with third, B with fourth, C with first, and D with second. A is connecting with fourth, B with second, C with third, and D with first. Or A is connecting with second, B with first, C with fourth, and D with the third one. So from these options, you have to select the correct option, which are indicating the correct match between the list 1 components and the list 2 components. So you have given some time, try to solve this, then we will see the correct answer. Okay, let's see. So for this given question, the correct answer is option D, that is A connecting with second, B with the first, C with the fourth, and D with the third. So the A in the list one is physioption, which is also known as physical adsorption. First of all, it is an exothermic process. Okay, exothermic means during this process, the heat is going to be released. You are going to obtain the heat after the completion of the process of physioption or physical adsorption. Secondly, the delta H, that is enthalpy change for this process, is between 20 to 40 kilojoule per mole. Okay, that is why A is connecting with the second component present in the list 2. Okay, so I want to mention that they are the question which we are discussing and the concepts which we are using in this question are the remembering thing. So basically you have to remember them. There is no logic. This is basically a simple concept that this is definition, this is heading. Okay, you have to learn that physioption includes the enthalpy change value of this much. What is chemisorption, right? And what is analytical application or adsorption? What about it? That's how you can match it with the correct pair and present in the list 2, right? So A is correctly matching with the second component present in the list 2, that is 20 to 40 kilojoule per mole. If we talk about the second thing, that is chemisorption. So physioption driven by weak van der Waals forces allows for multiple layers of adsorbate molecules to form on the adsorbent surface. Okay, so basically chemisorption and physioption are two concepts. Okay, so in the physioptions, the weak van der Waals forces are present, which allows multiple layers of adsorbate molecules to form. Okay, multiple layers by which are binding by weak van der Waals forces to form the adsorbent surface over which the adsorbate or adsorbent is going to, or the catalyst is going to attack. Okay, or is going to adsorb, you can better say. Meanwhile, the chemisorption process, on the other hand, involves strong chemical bonds between the absorbate and adsorbent, okay, which restricts the adsorption to a single layer. In the chemisorption, as the name says, chemi, that means something chemical or chemistry is happening, the reaction is happening. So in the chemisorption, strong chemical bonds are present between the adsorbate and the adsorbent, which restricts the adsorption to a single layer. That's why only up to the single layer the adsorption is going to happen. That's why the chemisorption is correctly matching with the single layer adsorption. Okay, that is B with the first one. Now the third one, that is this reaction, it is a heterogeneous catalysis. Why? Because in the heterogeneous catalysis, as the name says, hetero means different, homo means same. So in the heterogeneous catalysis, medium and the catalyst are in different phases. That means the medium in which the reaction is happening and the medium in which the catalyst is present are different. So if you see this reaction, the reactants and the products are in the gaseous forms. Meanwhile, the iron is going to be or is present in the solid form. So the phases or the mediums are different, right? So in the heterogeneous catalysis, medium and catalyst are in different phases. That's why C is connecting with the third part, that is chromatography. And the D, that is given as analytical application or adsorption, it is connecting with that chromatography, particularly adsorption chromatography, utilizes adsorption to separate and purify the mixtures. Okay, so that's why analytical application or the adsorption process is included in the chromatography process, and hence the D in the list 1 is matching with the third component in the list 2. Because in the chromatography, which we use to separate the layers or to separate the mixtures, okay, chromatography is a process which we use to separate the mixtures or purify the mixtures, you can also say. So the adsorption process or the concept is used in the chromatography to separate and purify the mixtures. That's why the D is connecting with the third component in the list 2. Okay, so I can't go back, okay, or try to go parallelly with me. That would be good. You can catch this lecture later. Okay, so I am moving to the next question. So this is a JEE PYQ and this is covering the NCERT sections 3.3.2. Question is saying that the rate constant for a first order reaction is 20 minute inverse. Okay, so we have given a rate constant value for a first order reaction, that is 20 minute inverse. Time which is required for initial concentration of reactant to reduce to its 1/32 level is dash multiplied by 10 to the power minus 2 minutes. So you have to identify the time which is going to be required for the reactant initial concentration to reduce to its 1/32 level. Okay, you have to give the numerical, or you can say the integer answer, because multiply by 10 to the power minus 2 minute is already written here. So you have to answer your answer, you have to convert your answer in the nearest integer. And you can also use some given value, that is ln10 you can take as 2.303, log 2 as 0.3010. Okay, this question has been in the 2023 JEE examinations. The options provided here for this question are 25, 17, 11 or 5. So you have given some time, try to solve this and then we will see the correct answer. Okay, let's see. So for this given question, the correct answer is option B, that is 17. So what are the given values we have in this question? We have given the rate constant value for a first order reaction, which is given as 20 minute inverse. We have also given that the A, that is the final concentration of our reactant, is going to be initial concentration divided by 32. That means 1/32 of initial concentration, right? So at this concentration, you have to tell the time. So we apply here the integrated rate law for a first order reaction, which is given by T is equals to 2.303 by K log of initial concentration divided by final concentration. T here is representing the time for this change of initial concentration to final concentration. K representing the rate constant, and another things are okay. So this is an integrated rate law for a first order reaction we use. So T is time, K is constant, rate constant, A naught is initial concentration and A is the final concentration. Now on substituting the given values, we have given some values, so we substitute that in the integrated rate law. Now we can write or rewrite the equation as T is equals to 2.303 divided by 20, because 20 is the rate constant value given, right? So 2.303 divided by 20 log of A naught initial concentration divided by final concentration. Final concentration is A naught by 32, right? So initial is going to convert to the 1 by 32 times of the, okay, final is going to convert to the 1 by 32 times of the initial concentration. So we put the A naught by 32 at the place of final concentration. Now you can simplify this, and this will simplifies to T equals to 2.303 divided by 20 log of 32, because this A naught will cancel out. Remaining thing is only 32, which here from the denominator go in the numerator. Let's say this is first equation. Now for logarithmic calculations, because we have log 32, right? So we know that we use this, that 32 you can write it as 2 to the power 5. Okay, why we are converting this into this? Because we have already mentioned in the question the log 2 value, which you can use in the calculation. So log 2 is equals to 0.3010, right? So you convert the 32, or you can write the 32 as equals to 2 to the power 5, right? So log of 32 will become equals to log of 2 to the power 5, right? Log of 2 to the power 5. Now you can write log of 2 to the power 5 as 5 log 2, right? Whatever is present in the power, it will go in the product form. So 5 log 2, using the logarithmic property, log m to the power n is equals to n log m. Now log 32 is going to be equals to 5 multiplied by log 2 value, which is already given as 0.3010, and this is going to be equals to 1.505. So log of 32 you can use as 1.505, because log 2 value is already given. So now we are going to put this log 32 in the equation first. Equation first was T equals to 2.303 by 20 log 32. So when you put the log 32 in this equation, T will become equals to 2.303 by 20 multiplied by 1.505. Now when you solve this, this is going to be equals to, T is equals to 3.465515 upon 20. Okay. When you do this fraction, it will be equals to 0.17327575 minute. Or you can also say, you can also write it as T is equivalent to 17 multiplied by 10 to the power minus 2 minute. Right? Why we have written it? So as I said, some students didn't read the answers correctly, and in hurry they will mark anything as their correct answer. Okay, whatever is matching. And the question in the mains examinations or the high level examinations, the question or the question maker will trick the question with this fact that they are going to put the options such like that you are going to get the as your answer from those one of the incorrect options, and you are going to mark those incorrect options. Okay, so remember here in the question already mentioned that you have to identify the time dash multiply by 10 to the power minus 2 minutes. So the answer will be whatever that you are going to fill in this dash. Okay, and it is already mentioned that you have to tell your answer in the nearest integer form. So if your answer is coming as 0.17327575, let's say, you can write it in this form, something multiplied by 10 to the power minus 2, and that is going to be 17 multiplied by 10 to the power minus 2. So your correct answer is going to be 17. Okay, so your correct answer is going to be 17. In the examination, there is no use of calculator you are going to do. That's why they already mentioned some tricks here. Like in the question already mentioned log 2 value, log 10 value. So think about this. That's why they are providing these values, because you have to modify or you have to solve in such manner that you are going to use these values. Okay, you can't identify what is log 32, but you can write log 2 to the power 5 as 5 log 2, and then log 2 is already given. Simple multiplication you can do, and you can already uh, like generally in the questions up to 2 digit or up to 2 decimals, the question has been asked its solution or its answer. Okay, not in this deep level. So you can even solve up to 2 digits also. So our final answer is coming out as 17 from for this question. Okay, let's move to our next question. So this is a JEE PYQ, and this is covering the NCERT section 3.3.3. The question is saying that A and B are the two substances which are undergoing the radioactive decay in a container. Half-life of A is 15 minutes and that of B is 5 minutes. If initial concentration of B is 4 times that of A and they both start decaying at same time, how much time will it take for the concentration of both of them to be same? You have to tell your answer in minutes. So try to understand the question first of all, what it is asking. We have given two substances A and B which are radioactive and which are undergoing the radioactive decay process in a container. We have mentioned the half-life of A and B. Initial concentration of B, that is B naught, let's say. Initial concentration of B is given as 4 times of A. Now, they both are starting decaying at the same time. So you have to tell the time that they are going to take for concentration of both of them to be same. So their half-life relationship is already given. Okay, their half-life value is given, their concentration relationship is given. You have to tell the time they will take to have the same concentration. Basically, this is the question. So this question has been in the 2023 JEE PYQ and JEE examinations. So the options which are provided are 15, 19, 11 or 30. So you have given some time, try to solve this, and then we will see the correct answer. Okay, let's see. So for this given question, the correct answer is option A, that is 15. We have given, so first of all, we will see the given values. The first value is the half-life for the A component, which is 15 minutes, and half-life of B is 5 minutes. And it is already given that the B naught, the initial concentration of B is going to be 4 times of initial concentration of A. So the concentration of a radioactive substance decreases exponentially with the time. We will use this concept here, that for a radioactive substance, concentration of this will going to decrease exponentially with the time. Now the decay constant, that is K, is related to the half-life by K is equals to ln2 by T half, right? So basically, the radioactive decay follows the first order kinetics. Okay, and the first order kinetics, we have studied that the relationship between the half-life and K is given as ln2 by the T half. So concentration of the substance at time T is given by concentration of substance at time T is equals to initial concentration multiply by e to the power minus kt. So this is the relation which we are talking about, that concentration of radioactive substance decreases exponentially with time. Now, our first step should include the calculation of decay constant for A and the B components. So the Ka, the rate constant for the A, is going to be ln2 upon T half of A, ln2 upon 15, right? Because the half-life for A is 15. Similarly, the Kb, that means the decay constant for B is going to be ln2 by half-life of B, that is ln2 by 5. Now step 2 includes the concentration equation. Write the concentration equations for A and B at the time t. So we have general equation. We can write it as A at time t is equals to A naught e to the power minus kat. Okay. This is going to be equals to A naught e to the power minus Ka value. So Ka value we just calculated here. So ln2 by 15 multiply by t, right? ln2 by t half we take because, as I said, that radioactive decay follows the first order kinetics, and for in the first order kinetics we take the half life of a reaction is equals to ln2 by k. Okay, from here we are taking, from there we are taking ln2. So we put the concentration, we write the concentration equations for A, and similarly for B the concentration equation is going to be equals to 4 times of A naught, because B naught is 4 times of A naught, e to the power minus ln2 by 5 t. Yes, ln2 is basically 0.693. You can use that also. So you can write the B concentration as 4 times A naught e to the power minus ln2 by 5 t. This is basically Kb value which we have put from here to here. So we have written the concentration equations for A and B. Now step 3 includes the setting of the concentration equal and solve for the t time. So when you put these equals, that the concentration of A at some time t is going to be equals to the concentration of B at some time t as per the given condition in the question, we put the value equals. So A naught e to the power minus ln2 t by 15 is equals to 4 A naught e to the power minus ln2 by 5t. Now you equate these two things because A naught will going to cancel out. So e to the power minus ln2 t by 15 is equals to 4 e to the power minus ln2 t by 5. This will become e to the power minus ln2 by 15t plus ln2 t by 5. We just equate these. We take this exponential term here on the left hand side and solve it by adding the powers. This is going to be equals to 4. Now you solve this. You take the ln2 t as common because they are it is present in both the values. So when you take ln2 times t common, inside the bracket the remaining thing will be 1 by 5 minus 1 by 15, right? Because 1 by 5 in plus and minus 1 by 15. So you have to solve this. This is going to be equals to 4. So it will be ln 2 times t, 2 by 15 is equals to 4. Now you have to take the log on the both sides. ln e to the power ln 2t 2 by 15 will become equals to ln 4. We take the log at the both sides. Now you know ln base e will become 1 and power, whatever is present in the power, that will go in the product. So ln 2t 2 by 15 will equals to ln 4. This will going to be as it is ln 4. Now t from here will going to be equals to ln 4 divided by ln 2 and 15 divided by 2. Right? You just have to rearrange the terms. So t is equals to 15 by 2. You can write 4 as 2 to the power 2, and using the logarithmic property we can write it as 2 ln 2. ln 2 will cancel out and t will come out as 15 minutes. 2 will also cancel out. Okay, so this question includes some calculation. You have to calculate very significantly, or very like effectively to get the correct answer. So T here for this question, the time is going to be equals to 15 minutes. Okay. Thank you so much.